Hey everybody, it's Cal here from Wise Guys Tutoring, and today we're going to talk about graphing linear equations. So basically how to graph a line using the equation. So let's do it. First, you should know that there are three major forms there of the line equations. The first one here is called the slope-intercept form, and I'd say this is the most prevalent one. We'll focus on that. Second one is the standard form, which looks like this. Right, I'm only using variables as space fillers, but I'll show you what they mean with examples. And the last one is called the point slope form, and it looks like this. Okay, so like I said, we're going to be focusing on the first one, which is the slope-intercept form. So let's take it over here, and at the same time that I'm showing you what this looks like, we can also talk about an example with a numerical example, so that it's easier to follow. The first thing we need to discuss is what m is, and this is called the slope, or some people refer to it as the gradient, same thing, and it's basically how inclined is your line. Okay, that's what that's going to affect. And this can be better defined as m is the rise over run. So this is how many steps up or down, as we'll see, over how many steps forward. By forward, basically I mean right. Okay, in this case my slope is 2, and we know when there is no denominator, it's the same as saying 2 over 1, right? So this is going to be 2 steps up for every 1 step forward. And I'll show you what that means in a graph in a sec. This one here is called the y-intercept. Y-intercept. It's where your line crosses the y-axis. Where it crosses the y-axis. And this always happens when x equals 0. Alright, in this case, here is my y-intercept. That means our line over here, once we plot it, which we will, should cross my y-axis at 1. So how do we plot this now? Best thing to do is to use what we call a table of values. Okay, a table of values look like this. You got one column for x and you got one column for y. Let me use a line here to make it a little bit cleaner. There you go. So, for example, let's use the value of 0 for x. Now I take my original equation, right? Remember, it was 2x plus 1, right? So instead of x, I'm going to substitute 0. This is going to give me 2 times 0 plus 1, which gives me 1. If I use x is 1, I get 2 times 1 plus 1 gives me 3. And if I substitute x is 2, that gives me 2 times 2 plus 1 equals 5. And we can keep going forever, right? 2 times 3 plus 1 is 7. Right. Now, I want you to think about these combinations. These are all combinations, right? When x equals 0, y equals 1. This one told me when x is 1, y equals 3. And this said when x is 2, y equals 5. And these endless combinations are actually coordinates. These are coordinates of points which exist on this line. Okay, so each one of these is a point on the line. So without further ado, let me bring in the graph here. So let's try to plot these points. So whatever value for x you have is in this column here, and whatever value for y you have is in this column here. Now when x equals 0, then y equals 1. And when x equals 1, y was 3. Right? And when x is 2, it gave us that y is 5. Okay, so I think that's going to be enough for me to plot the line, because I'll be honest with you. All you actually need is 2 points. 2 points anywhere make a line. But we use 3 just to be safe, because you never know. You might have gotten 1 point, which is, for example, when x is 1, You might have calculated it wrong and gotten a point there or something like that. And then you wouldn't know if your line is correct. You would have made a line going somewhere like that, which of course would be incorrect. So by plotting 3 points, we can ensure that we get, a correct line. Okay, so you'll also notice that my point of 3 and 7 is also on this line, right? Any combination here which fits this equation means it is a point on this line. So I'd like to discuss the slope with you now. Think about it as the rise over run, right? Now let's take any point. For example, let's work on this point here, which is 1 and 3. If we take 2 steps up, we're at 5, and then we take 1 step forward. That gets me to the next point. And if you keep doing that, 2 steps up and 1 step forward, you get exactly to the next point. Even if we had started here, you get 2 steps up to 3 and then 1 step to the right. Okay, so that's what the slope means. Okay, the slope is consistent throughout this whole line. That means anywhere you are on this line, if you want to find another point on this line, all you have to do is take 2 steps up and 1 step to the right. The other thing we can see is the y-intercept, which we already had figured out, right, from this equation, that it's going to be 1. So if I look here, where does it cross my y-axis? It crosses exactly at 1. One last thing I'd like to tell you is that what the slope does is tell me how inclined it is, right? So if I have a slope of 5, what that means is my slope is going to be very inclined. It's going to be 5 steps up for every 1 step forward. I would get a point here. And that means I would get a line more inclined, much more inclined, like this, right? That passes by those 2 points. And you might get something like a slope equals, 1/2. So what that means is I get 1 step up for every 2 steps right, or 2 steps forward, if you prefer. So 1 step up for every 2 steps forward. Now this line looks more like this. So it's much less inclined. So that's the significance of the slope. The significance of the intercept, okay? Let's clean this up a little bit. The significance of the intercept would have been a translation. So if B was 3, for example, instead of being 1, that means my line would have started here. It would have been parallel though, right? Because it didn't change slope or anything. It just kind of changed the intercept. So it would follow this path of 2 up and 1 to the right. And obviously we can also say that if B was, for example, -4 or something weird like that, it would be down here. And again, it would have the same slope because we haven't changed the slope. We've only changed the intercept. So it would be parallel to these other lines. It would just be translated downwards. So that's the significance of the y-intercept. Now let's check out the standard form.